Hi, yeah, I will talk about some chatbots today, how to build an intelligent chatbot. Obviously, in 45 minutes, it's very hard to tell you how to do it. I'll just give you some hints how to do it. First things first, yeah, nice photo. A few words about myself. Okay. So I'm doing machine learning for about 15 years now. I obtained a PhD in 2015 in machine learning and computer science here in Cracow. And in 2010 I figured out, well, maybe I should make my own company. And yeah, Codete is my company actually. We're based here in Cracow. We have also an office in Lublin. Since 2010 now we are 130 engineers. Also doing chatbots, doing NLP, doing machine learning. Obviously in 2010 it was very hard to sell machine learning, but now, as you probably know, it's a buzzword and everyone wants to do it. Yeah, if anyone of you is interested, I have published some research papers on skin cancer diagnosis, how to build your machine learning model that will recognize skin cancer. Here are some papers, and here are some contact details. Just drop me an email, call me if you have any questions regarding machine learning. Yeah, or just ask me any question after the talk. So, yeah, buzzwords. First thing actually that I would like to tell you about: machine learning, deep learning, NLP, big data. Right? It's all buzzwords. There's actually one story that I would like to tell you. Last year in May, I was on a conference called The Race of AI in Berlin, and there was one director that actually approached our booth, and we talked about some business. And after that, he actually told me a story that one customer approached him, saying, "Okay, we would like to develop a machine learning solution, artificial intelligence solution that will reply to emails. So an NLP solution that will actually get the text, understand it, generate a response, and send it. Simple." Okay, they spent $2 million on that. The developers did it, data scientists did it, they have developed it, tested, implemented, deployed, and it's working well. But this director took a look at the solution after they deployed it, and he figured out that actually this solution is replying to 50 emails per day. And he came back to the customer asking, "Why did you spend so much money on 50 emails per day? It is cheaper to hire someone, and this person would do it better than 1 hour per day." And the customer said, "Well, yeah, you're right, but now we can say that we are doing artificial intelligence." Right? So they spent $2 million just to say that they are doing artificial intelligence. So this is buzzwords, right? We shouldn't actually follow that. I have one actually my customer that came to us saying, "Okay, we would like to use some machine learning models here to solve this problem." And we did our research and said, "Well, yeah, you could, but using regular expression give you 100% of accuracy, and it's cheap and simple, right?" And they said, "Well, yeah, but we got our European Union funding for doing some artificial intelligence stuff, and we cannot tell them that we just use regular expressions for that, right?" So they have a problem. I mean, we did it, but it doesn't make any sense. So please keep in mind that machine learning, NLP, it's not always the solution for everything, and also for chatbots, right? I'm not sure how many times did you had a chance to actually speak with a chatbot or talk to someone to something like a chatbot. And probably your experience on this is like, they are annoying, not really intelligent in many cases, because they are developed in a very simple way. And I will go through some 3 different types of chatbots to show you what kind of chatbot you can actually implement and why they're different, which one actually you should follow. I mean, what kind of chatbot you should implement now. So when it comes to chatbots, it's just a new interface. Right, we had a web interface in the late of the 90s. Then, smartphones came. So there was another interface to contact the customer with our smartphone, and now we have another way of contacting the customer with the chatbot, right? So it's all about selling, advertising, in just a different way. One example. Here we go. Do you see this one? Do you know it? Ty? This is just an example of well, it's a tweet bot. It was developed before Trump became a president in US, right? And it was a chat bot, was implemented by, do you know what kind of company could do it? There's only one that comes to my mind, right? It's Microsoft. Microsoft developed it. They have published it, deployed a tweet bot that was actually a teenager. It was trained to be a teenager. After 24 hours, this bot became a Nazi. Nazi, racist, hating, anyone else that is not white, and so on and so on. And this is one of an example of the response of the tweets that actually this bot tweeted on Twitter. Obviously, they disabled this bot after 48 hours because they had a leak. I mean, there was a way to train this bot, and some people actually figured out how to train this bot in a different way, not just using the tweets. And this is how the bot became a Nazi bot from a teenager, loving dogs, cats, and so on. And obviously, there is another example, but we don't have enough time to show it. Here's a link how actually bots were used for the last US elections. Bots, chatbots, trolls, and so on. When it comes to chatbots, you have different kind of bots. Just to mention a few, and you have different platforms here, right? Dialflow, Siri, Chatfuel, Cortana, and so on and so on. So you have different kind of tools that actually you can use to implement it. And even you can buy a chatbot now. So we have even some markets where actually you're going to a market and buying a chatbot for your case. So this is how it looks like now. Have you ever used any of this tool? Anyone implemented a chatbot before? Okay. So when it comes to different type of chatbots, we can actually divide it by interface, by privacy, or by the usage. When it comes to interface, we have automation chatbots. I mean, it's not really chatbot; it's a bot, right? We can call it well, Jenkins, for example, we can think about it like a bot because it's doing some work for us, some automation work for us. Audio, like Alexa, right? Siri, and text. So everything what is on Facebook, Slack, and so on. Privacy. There are chatbots that are on-site, and some of them are online. On-site means we are not allowed to share our data with, for example, with Google or Amazon. There are some companies like banks where we are not allowed to do it because they don't want to share the information what the customers that the customer that actually use the chatbot, they don't want to share this information with companies like Google or Amazon because of some legal stuff and regulations. And online, where actually we use the API that is available by Google or Amazon or any other provider. And we have also superbots, domain bots. An example of our superbot: Google Assistant, right? Yeah, because it covers many domains. And obviously Alexa, right, is another superbot. We can add new skills to it, but this is an example of our superbot, and we have some domain-specific bots. So the platforms again, you know this guy from the studies, maybe? Yeah, exactly. Turing is the guy that is known as the godfather of artificial intelligence. He introduced the Turing test, where we are able to distinguish if it's artificial intelligence or if it's a human. if you have a chatbot, what is the one of the simplest way to figure out if it's a artificial intelligence or a human? How do you think? It's a chatbot, and you can type something. What would you type to figure out if on the other side there's a human talking with you, or is it artificial? I mean, some machine learning method. Yeah, but something that is simpler. No, it's easy. What people do not so good as the computers do. Exactly. Let's ask what is actually 2054 multiplied by, I don't know, 4,000, whatever, right? For a computer, it's just like that, right? And for a human, okay, let's take a calculator, and here's the response, right? Obviously, we can simulate it with artificial intelligence, like, giving some sleep, right? I'm calculating, right? But it's easier actually to figure out if it's what's actually behind. And the Turing test is it's a test where actually we can figure out if who is actually on the other side of the chatbot. So when it comes to the different types again of chatbots, we have retrieval-based, we have rule-based, and we have generative-based actually chatbot. I will talk about the three ones. So retrieval-based, rule-based, retrieval-based, and generative-based. Rule-based are the simplest one, right? Because it's a set of rules. Retrieval-based, they use some machine learning methods behind. And generative-based, well, for now only just a few companies did it, like Google, Amazon, and so on, because they have a lot of data. And I will explain in a minute why. Okay, so rule-based. It's a list of questions and list of answers, right? And we are just going through the questions. So let's imagine someone is typing something, and we are trying to find this question on our list, right? Here's one of something too difficult to do. I mean, it's not the question will not be exactly like the one that we have on list. So we need to find some method. Implement some method that will measure the similarity, right? So implement a similarity measure. Here we go. Okay, I will come back to this one. And there are some different methods, like the Levenshtein distance. It's all of the methods here are available here with the two libraries for Python, and all of them based on strings. Based on strings, so it means, let's say we have, I should have an example. No, I don't have one. Just a second. Let me find it. It should be somewhere here, I guess. The Levenshtein distance should be somewhere here. Sorry, I have 10 notebooks. That's it's Tokenizer, it's NLP. Never mind. Let's imagine you have train and trainings. Is it similar? No. Train and trainings. I mean, from the string perspective, yes, right? Because they have something in common, but from the human perspective, not at all, because train is something that has nothing to do with our training, and these kind of methods are not perfect because of that, because they measure the chars in the string and try to find here the similarity. What is the better idea to do it? I will show you. Here we go. But before that, I would like to, well, it's NLP that I would like to introduce you that can be used to build, well, to use machine learning at the end. And there are some methods in NLP. NLP is actually divided into, NLP is natural language processing. there is NLU, which is natural language understanding. We have also NLG, which is natural language generation. And there are different methods like sentiment analysis, summarization, question answering, or just name and entity recognition methods, or part of speech tagging. I will show you the methods in a minute. But they can be used to process the text in a more intelligent way. Some of the such methods are tokenization, lemmatization, and stemming. Let me show you. So you know Jupyter, right? You have used Jupyter before? Clear. It's a question, or is it? Okay, you used it. Okay, cool. So I don't need to explain how does it work. Let me go back. So I will not go through all of it because, as you see, there is a lot of examples here. So NLTK is one of the most popular library for NLP. You have some books that you can use for as examples here. Just an example how to download it. You can count the number of some word accuracy and so on. So you have some methods to work on the text. You can obviously build your own corpus. Corpus is the text. It's a text that is inside. That is actually corpus is a text that with some methods that you can use on it. So here are some exercises, and yeah. So here's an example of a Trump speech that I actually added here as a corpus for NLTK. But that's not so important. We can measure the richness of the words. Here's the Bible. So the Lord is very high. King, Israel, man, God, and so on. We did an analysis on music texts, on the lyrics. Yeah, sure. Yeah. Sorry. Word? Oh, okay. Yeah. Now it's too big. Maybe I'll just do it this way. Here we go. Fine. We did an analysis on music lyrics, on songs, and divided it by the type of the music, right? And what kind of music do you think? What type of music do you think the most common word is God? It's metal. Yeah, this is the type of music. We have checked many lyrics, and metal is the word that actually appears most often in, obviously, God, and you have also devil, and then this kind of words in the heavy metal music. And obviously in the pop music you have love and this kind of words that are appearing. I don't have the statistic here because it's a different training, different presentation. Just to give you an overview what actually you can do with the NLTK and the corpus. So if you would like to work on text, there's an example of training and trains. Well, it's just one word, but usually we don't work with just one word, we work with sentences. And to analyze the sentence, we need to divide it somehow. And here's an example how to split the text into words with regular expressions. What's wrong here? What do you think? Here's the output. What's wrong with the output here? Why this case is not, well, it's wrong. Okay, we don't have enough time. Dot. The dot is here wrong. Why? Because the dot is it's a punctuation mark that says, okay, this is the end of the sentence. Whatever comes next can be related to the previous sentence, but it's the end of this sentence. So whatever we analyze in this sentence is around between dots, right? Dot. It can be a dot, it can be a question mark, it could be an exclamation mark, and so on and so on. So different kind of punctuation marks. And this is how you can also split the the same, but using the string methods with Python, so the split method, you can get the similar thing. And with some regex, you can also do divided text by sentence like that. But it's not perfect. It's not perfect. To do it properly, you should use the tokenization methods. You can implement your own tokenization method. Here's just an example. As you see, the dot is a separate token. A word, in this case, is a token, right? And it's fine until, and obviously you have the sentence tokenizer. It's fine until we will not analyze, for example, the tweets, like here. It's working well until we get something like that. And here I have two examples. One of it is the word tokenizer here. Doesn't make too much sense, right? And the tweet tokenizer below. Makes more sense. Especially if we're analyzing the sentiment, right? Because this here, this sign can say, well, we can think about, well, it's something positive, right? And here, in this case, it's very hard to figure out what's really, what's positive here or negative. So you can build your own tokenizers. NLTK provides some examples. And you have more tokenizers like here. So it's about expressions and grouping the expressions. So it is another tokenizer to analyze the text and make it more, make it more intelligent. Okay, here's an example. So how to build your own tokenizer. Yeah, simple solution for that. And this is one of the methods. The other method is part of speech tagging. So we have already tokens, so we have words. And the next step to analyze text is to get the meaning of the word. If it's a noun, it's a verb, and so on. And you have tags, so part of speech tags. Here's just a short list of the tags, like noun, noun singular, noun plural, verb, and so on. So having this information, we can analyze the text in a more intelligent way to understand what's in the text. And you have the full list here of the tags for NLTK. So you see there's a lot of many tags here for part of speech. Tokens, stop words. Yeah, also NLTK give you you can get the stop words for English, for example. Some of the words doesn't mean too much, like and, I, we, right? It doesn't say too much. So this is pause tagging. If you have another example, and yeah, it is a new Unicode. There are two sentences, one in German and one in Portuguese. How to reduce the special characters like the umlaut, the German umlaut, without losing the information. And here are some examples how to do it wrong. And here's how to do it, normalize it properly, just to get the umlaut to R, umlaut to R, and so on. I mean A umlaut. And well, there are some other methods like lemmatization. We have words like do, does, doing that mean the same at the end. So using lemmatization methods, we can move it to a word that is the base word. What is important here, the base word always exists in the dictionary. It means something. Where you have the stemming, so I have the example here, and you can actually say, okay, what's the base part of speech for words? And you have stemming that are reducing the words to the root. And you will get something like that. Some of the words doesn't exist in the dictionary. It's a set of rules. Each steamer has a different list of rules how to change the words, right? How to reduce how to cut the last few letters in a word. Where is it used? How do you think? Search, Google search. Yeah, for example, because it's easy to just go to the root and find it. Yeah, so that's one thing. And this is NLTK. SpaCy is, well, NLTK is a very old library. SpaCy is new, just a few years, really, on the market. And it's, this is the most popular, I think, library framework, actually, for NLP. That works, it's easier to do. So you have again, an example of Trump speech here divided by sentences. Very short. What is important here is to load the language. And I will show you why. I mean, why you need to load the language model, because it's vectorized, and I will show you that in a minute. So let's go back to slides. Here we go. Here we go. No. But before that, I would like to just give you an overview of machine learning, because I hear quite often that people are saying that machine learning is that, deep learning is ruling the world, and so on and so on. It's wrong. I mean, deep learning is part of machine learning. It's a subset, because deep learning methods are based on neural networks, and neural networks are part of machine learning. Or machine learning is a method to implement artificial intelligence. It's not perfect, but for now, no one else figure out there is something better than machine learning. And I think that machine learning will not really solve many of the problems that we have now. There are some different approaches, but they are too young, not really mature to really build artificial intelligence. And this is how machine learning works. So it's quite simple. So we have different data sets. We have training phase and prediction phase. We have also different other phases, but these two are the most important. So we have extracting the features. I'm running out of time? Not yet, okay. Because it's just 10% of the presentation. So, yeah, I will, Okay, so let's do it fast. So let's say skin cancer, right? I mentioned you that I did some research on skin cancer. So you have moles that you're analyzing on the image. The features are the size, the color, if it's symmetric, if it's, what kind of border is it. So we are extracting the features from the image, from the text, and then give it to the machine learning method. If you have deep learning method, very often you are using raw data. Just putting it and saying, oh, whatever. You have so much data that actually it should learn somehow. And then you get a label. Label means cancer, not cancer, right? So easy. I mean, it should give you the right answer, right? If it's done, if it's trained properly. I hope you will not have the chance to actually use it for this case, obviously. And there are some other methods like that are used for natural language understanding, part of speech, noun chunks, name and entity recognition. It's more intelligent because, well, just let me show you. Here we go. Okay, this is stemming, sentence extraction, noun chunks. Okay. These are the noun chunks from the Trump speech. Okay, in this case you don't get too much, but at the end you will get the nouns from the text, but not just nouns, but also the nouns in the meaning that if there is a combination like United States of America, this is a noun chunk, right? Mr. President is a noun chunk. There are not two nouns like Mr. and President, but it's like my wonderful friend, for example, right? And so on and so on. So you can get more information about what's in the text just getting the noun chunks. Easy thing. Okay, Trump speech. This is one example. Nouns, America, God bless you, God bless the United States. So you know that someone that is actually wrote this text did something about United States, I guess. And actually it's a Trump speech, so yeah. And name and entity recognition. So the part of speech tags, they don't say too much. I mean, We know that's okay, it's a noun, it's a verb, that's cool, but for humans, for us it's more interesting like, okay, is it a person? It's our organization. Maybe it's a location, right? Kansas City. GP means it's a city. I mean, it's a location on the map. GP, right? Org means it's our organization. Even Black History Month, time tonight, right? This is more valuable for us when we analyze the text. So you have it also available with Spacey. Easy to do. But if you would like to use machine learning, can we use strings? Here's an example how to do it. Broadcasting today, live from Cracow on chatbots. And you have nouns, you have the part of speeches, and also the name and entity recognition in this one sentence. But, okay, but using strings, are we able to use machine learning? Not really. So what should we do? Convert strings to a mathematical representation. In our case, vectors. So, like here, right? So this is a three-dimensional space, and we have man, woman, king, and queen. The arrow means our relation, and the position, right? We see that the king to a queen is like a man to a woman, right? Or walking to walk, swimming to swim, and so on and so on. So we are moving the words to a vector that can be placed in a feature space. This is a three-dimensional space because it's easy to draw. And Spacey, in the small model, it uses a vector for each word that is a size of 384 variables in it. So it's obviously hard to draw it. It's even hard to draw four-dimensional space, right? How can it be done? How actually we do it? Anyone did it before? Bag of words at university? Anyone? Something else? Only bag of words? Okay. So just to give you an example, again, broadcasting live from Cracow. This live training is on chatbots. And just 2 sentences. We are putting it back of words. We are taking all of the words, putting into back. There's a mistake here. What is the mistake here? Then the dot is here, in this case is not really important because we are putting it all. Live is twice in the back. It should be once. And the representation of the sentence is like that, the first one and the second one. So we converted the sentence to a vector representation. Very simple method. 6 line of code. Let me take a look. This is an example. Yeah, you have it with a scikit, obviously, right? Scikit-learn. But if you would like to implement it, it should be like, yeah, that's one of the implementation. You can do it fast. I mean, it can be small. So not 6, let's say 20. But it's very, very easy to do. And at the end, you get a bag of words like here. So for this text, and the representation for each sentence. What's wrong with that? With this approach? You can have different sentences that means something totally different, but they will have the same representation, right? There are different implementation of bag of words. You can have a binary. You can have it like here. We can count it with the count vectorizer. There's another solution that is giving more information. Is Tf-Idf, and it promotes the words that are not so often used in the text. Right? Because if we say I, and we have I in every sentence, does it mean something? Not really. So the value of I will be low. Where if we have a cat in one sentence, it will be high, because it says something for this sentence, right? And this is what Tf-Idf is about. Not too many, I don't want to go too many into the equations here. So just 3 sentences, right? Tom is not so important, where catfish and Polish is important. And yeah, and it calculates the the frequency of the term generally, and the inverse value of the frequency in the whole document, so in the whole text. So that's why we get proper values here, like this one. Okay. And there are many other methods to do it. I mean, these two are quite simple, just to understand how actually to move. But this was actually more doc2vec, so just the whole sentences. But we are using many methods for word2vec. This image is not really saying too much. So there are different methods. Transfer learning, n-gram model, bag of words, Tf-Idf, skipgram. One of my favorites is negative sampling. That is used. It is used in neural networks, but the goal here is to get to context. So get the meaning of the word based on the words that are, on the left, on the right of the word. I said before that the vector of the word in spacey is the size of 384. What do you think? Why is it 384? Why not, I don't know, 200 or 1000? And what does it mean, the first value in this vector? So it's quite easy. I mean, the number is not really a magic number. This is the lowest number that allows us to represent properly the data that we have in the text. And the values in the vector are like, let's say, animal, car, or I don't know, transportation, or there are areas, and the values in it are the probabilities of assignment to each of area. Like, animal, let's say, transportation, building, whatever you have, different kind of terms that can be related to this word. And retrieval-based chatbots, they use machine learning models to get the intent and give you a response. Let me give you an example. Here we go. NLE. Oh yeah, this is an example of trains and training. Sorry, it's in this notebook. So as you can see, it's it's quite similar. Well, we know it's not really similar. And there are other examples here. And here we use the vectors. So king, queen, horse, cat, desk, lamp. Obviously, king to king is 100% accurate. I mean, they are the same. Where king to queen is 0.33 in a range from 0 to 1, right? King and cat is quite high. High like king to horse, where, well, what is not so close? Desk and queen is not close. Lamp and queen is not so close. So just to give you some examples. Desk, queen, desk, horse for some reason is high. And the numbers are, they are based on the, it depends on the text that you use for training, right? That's clear. So if you use Shakespeare, probably there will be, horse, king, queen. But if you would like to, to find a word like computer, probably if you use Shakespeare books as for training, you will not find this word, right? So it's also important to know that what kind of text you use for training. And what is really cool here is that because we have vectors, not here, here, you can subtract man with a woman plus queen and you will get a king, right, as a value at the end. So you can do mathematical operation on that and get some values. Okay, so the goal of retrieval-based chatbots are to understand the intent, extract entities, and execute some tasks. Here's an example. I know Champions League maybe is not really the topic today. What are the recent Champions League scores? You can, for US, you can say, okay, NBA, of course, whatever. You get a message. There is an NLP engine somewhere here between, and the intent is Champions League, league recent scores. This is the intent that we recognize based on the trained data, and we know how to reply, right? Because we figure out, okay, this is about Champions League. It's an easy example because you can actually do a regex from Champions League, right? And you will get to the same. But if you have many examples, then it's not so easy to do it. And Rasa is one of the tools we use that actually can be used for retrieval-based chatbots. And here's the engine. It's a state machine where, well, someone of you mentioned that how to distinguish between our artificial intelligence and our human, right? And someone said that, well, you can say hi many times, right? And artificial intelligence usually will say, reply like hi, 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 right? And it's not really intelligent. But it's a state machine. I mean, it's changed all the time. So it means that at the first time it will reply hi, but on the second hi, we just, it will reply something different. It will be more intelligent, right? And how does it train? It's using some text, then using some vectorizer and classifier to train it, and then recognize it. Simple. Okay, analogy. How much time do we have? 5 more minutes. Okay, cool. So, okay. I would like to show you one example here. Okay, here's how to build one, how to build a word to vec with TensorFlow. I will not explain it because we don't have too much time. But you can find many of such on the internet. This is an example how to actually get the context. So we have live, we have and training. So with a window, we can change this window size, so we can take more words on the left, more words on the left, on the right, to get to know what the word is about. But there is one example that I would like to show you, because this is an example of how to reduce the 384 vector to a three-dimensional, for example, vector. We're using TSNA, and there are some other methods to reduce it, not to lose information. And here's an example of the implementation of the words in a two-dimensional space that I just did some time ago. This example, yes. Damn, I don't have internet. Okay, next time. But it's funny because if you put Warsaw, for example, if you put on an x-axis west-east, and on a y-axis city country, if you put Warsaw and Poland and then Berlin, Germany, it will be to the west from Warsaw. And again, if you take Paris, then it will be west from Berlin, and so on and so on, because it was trained like that, and it knows where it is. I mean, if it's more to the west or more to the east, and you can actually localize the city just by using the vectors, not without using the map. Obviously, it's just a funny example. Some negative example is another example of vectorization. Let me show you an example of NLU. Here is the example of a rule-based chatbot, a stock market advisor. Very simple, just step by step, going through rules, and that's it. It's called Greg because our CFO is called Greg, so I called him Greg because it's about stock markets. And Arthur is the sales guy, so he is a customer support chatbot, also a rule-based chatbot one. An example of there's a rule-based, and here you have similarities. Oh, it's not this one. Just a second. So here you have a generative-based one that I will show you in a minute. And I have still one that is our Rasa, I mean a retrieval-based, just a second. Let me show you. It's locally. So I know I'm running out of time, so here's an example. Intent understanding. Again, Champions League. You are training it like that. This is our server version in Python. I mean, just a request saying hi, and hi is the intent is greet with our 100% of confidence. Obviously for this example, because it was trained like that. But you can add more. You have the pipeline here to train it. In this case, we are using spacing and scikit-learn, but you can change the pipeline. Pipeline means the process from getting the data until it's trained. So we can use different methods to do it. And Rasa, they have some pipelines that are already defined. And here's an example of a HR recruitment assistant, how to do it, and synonyms. So the candidate, it can be developer, it can be data scientist, it can be something else. And here are the examples, how to do it. Just a small list of examples, and here I add candidate just to recognize the intent. So the intent is here, and you need to feed the argument with some examples to train it. It's really a small data set here. It's Anna, because in our recruitment department we had 4 Annas. That's why it's Anna, the recruitment assistant. And you can make it more intelligent, or even to use to make even responses. The uters are the responses, and you can even have the paths, right? So depending on the intent that is recognized, we can reply with a specific method, even with an image of a cat, right? So it's an easy tool to use. Obviously, the training here takes some time. I recommend you to use this one, and here are some examples. But this one, it's not JSON this time; it's a Markdown example. So the last thing that I would like to tell you about is the natural language generation. It is used by the generative-based chatbots, and they are using some deep learning, usually deep learning methods. Ngram model is not a deep learning method, to generate some unique output, so unique response. And if it's well trained, it's really giving good examples. Alexa, Google Assistant, they are using it to get the response. So the Ngram model, you know it already. The recurrent neural networks, they are used because they can define the output and output input size, and it's used for NLP. So the size of the output is the size of the sentence that you are outputting. And LSTM, which is a special case of the recurrent neural network that use some memory just to get the dependencies. It's still not perfect, but it's working better than the RNN network. Auto and chorus are recently very popular. To get to generate data, you have the encoder and decoder and the feature vector. It's a small vector that represents the data, just to generate new output. And GANs, where we have noise, we have 2 networks, the generator and the discriminator. They can both work separately. That generates new data as well. A really short summary. Advantages: rule-based chatbots, predictable, clear, principled, cheap. Retrieval-based chatbots identify the intent, so it's more intelligent. Easy to train because the dataset doesn't need to be big. Not too many question and answers, and it's more intelligent than rule-based. Generative-based, generic, intelligent, raw data. But on the other hand, rule-based is very often too simple and annoying. Not really intelligent. Retrieval-based chatbots are limited to question answers, not generic. But on the other hand, generative-based chatbots it takes very long time. Just to give you an example, I trained one of such chatbot. It took me 7 days on 50 GPUs to train it. So it takes some time to do it. Last thing, in March, because I'm an O'Reilly trainer as well, please join me in the Building Intelligent Bots in Python next month on the Safari platform. Or a few days later on how to build sentiment analysis. 3 hours training with some Python examples, step by step how to do it. Any questions? Sorry to be so fast, but yeah. It depends on what method you use. it depends. I mean, if you use a GVAL base, it doesn't need to take too long. If you have a generative base, yes, it takes usually long because it's, well, you have a lot of data. So because you have a lot of data, it takes some time. And using a chatbot to train another chatbot, well, you can you can take Google Home and Alexa, put them together, and let them talk, right, and generate some data, but not really to train. I mean, you could somehow as well, but it's not really, well, I didn't heard that someone really did it in this way. Any more questions? No. Well, Spacey, they have a support for Polish. I mean, they have a support. It's not. They are still in alpha stage, but you can use it. You can use it can be used. It's not perfect, but you can use it for tokenization, for all the stuff that actually is needed for building a chatbot. And you have many languages, not just English. In the stable version, you have English, German, Spanish, Chinese, Portuguese, and one Italian, and French. And in alpha, you have Polish, Hungarian, Finnish, and many other languages that are not so popular. So you can use it. It's in alpha stage. There are some in beta stage. It's not really worth. I mean, there are only 40 million people talking Polish, right? And so many people talking English, Chinese, or Spanish. So that's the thing. So you can try it out. Spacey. Any other questions? Yeah, sorry for being so fast again, but it's a training for 4 days, and it's hard to compress it to 45 minutes. Okay, cool. So thank you, and please join me in March. Thank you.